Hello Geography 271 students. So this is the help video for Lab 2, and Lab 2 deals with descriptive statistics. There's two parts to this lab, and each part has a separate data set that we need to work on. In the first part, we're going to look at data, precipitation data for Kelowna. It's monthly data, and it is from 1901 to 2019. And we're going to calculate a variety of descriptive statistics for this data set. The second data set looks at average grades given in science courses at UBCO. They're first year science courses, and it's 6 years of data from the academic year 2016-17 to 2021 to 22. So let's begin with Part A. And as I said, Part A is looks at Kelowna precipitation data, and you can see that data. It's up on my screen. And you can see it's organized by month, so it's monthly data, and the measurements are in millimeters of precipitation that fell throughout the entire month. Scrolling down this data set, I get to a little table area where we're going to calculate out the various descriptive statistics using Excel. So let's begin with January, and the first descriptive statistic I want to calculate out is mean. Now there's several different ways that you can do this. What I'm going to do is I'm going to just type in the formula that's required with the function to do the calculation. But you can also, under formulas, there is insert function. So insert function, I showed that in class. It simplifies the process so that you know that you're selecting the right function to calculate out the descriptive statistic that you're looking for. So anyways, back to just typing it in. So mean, the function is called average for mean. So I've typed in equals average, and then open bracket, I'm going to select my array of numbers. So it goes from B2 to B120, close bracket, return, and their mean is calculated. Next is mode. So mode is equal to, now there's several different functions that can calculate out mode. I'm going to use a function called multi-mode. So it calculates whether or not there are multiple modes in the data set. So it's mode dot multi, and then I've got open bracket, select my data set, close bracket, and return. Oops, I got a little error in my, let me do that again. So mode, oh, it's just mult. I put multi, and it's a mode dot mult. Press return. I'm still having problems. Mode equals mode mult. There it is, 38. Median. Oh, that's an easy function. It's just median, and then my array of numbers. Press return. There's my median. Maximum equals, it's just max is the function. Max. Return. And I've got the maximum. Minimum is just min. Select my array of numbers. And return. Range is going to be simply the maximum value, so cell B130 minus cell B131. Okay. Quartile is equals the word quartile, bracket, select my data, and then beside that I got to put what quartile I'm talking about. So 0 is the minimum. 1 would be first quartile, 2 would be second median, 3 would be third quartile, and 4 would be the maximum value. So I want the first quartile, 1, close bracket, return, and there is the first quartile. Third quartile is equal to the function quartile, bracket, select my data, array, comma, and I want 3. Return. So there's the third quartile. Variance is var dot p. There's several different versions of variance. Var dot p calculates out variance using the population formula. Var dot s uses the formula for variance that is specific for a sample. And we're considering this to be a population of data. Standard deviation is equal to STDEV, and once again, dot P to represent a population, open bracket, close bracket. So be careful when answering this question, and they ask, define standard deviation. You want to use the equation that is used to do the population version of it. Coefficient of variation is, we're going to use a formula, equals the cell B136 where we have standard deviation divided by the mean, which is B125, multiplied, so star 100, and press return, and there's my coefficient variation. To complete the table, just go copy and paste. I won't do all of them. I'll just do up to April so you don't get the answers and just copy them in. Okay, so that's what you need to do with the Excel spreadsheet, and that answers question 1. And then copy and paste your table into your Word document when you hand in the assignment. The question 2 goes through each one of these descriptive statistics and asks you for the calculated value for January and for June, and then give a word description of what this descriptive statistic calculates. It is in the notes. Try to use your own words. As I said, the two that you need to be careful of if you use the formulas is variance. We're doing variance is for a population, and standard deviation is for a population. And that's questions 1 and 2. Question number 3 asks, explain the significance of the different values of standard deviation calculated for the 12 months of study. If the dispersion of the data for each month was the same, then standard deviation should be a similar value. I think you're going to find out that it isn't. That there seems to be much more variation in precipitation in some months, less variation in other months. And I want you to identify that in your answer. So did you find different levels of standard deviation? And which ones had the lowest variability? Which ones had the highest variability? And what were sort of middle variability? Okay. So question 4. You are going to use your descriptive data to create some box plots, and you're going to do this by hand, and you're going to do it on this sheet that's available for download. Now you should be able to do this in a drawing program, or you could just print it off and draw it. I'll probably bring some copies to the lab. Just make sure it's neat, and of course what you're going to describe here is the actual box, which consists of the first quartile, the median, the third quartile, and then for our box plots that we're drawing, we're going to use the whiskers are going to extend to the minimum and to the maximum value in the data set, so you can get that from your Excel spreadsheet. And that's completes question 4. Question 5 asks, once again, in terms of the dispersion of the data, are the medians the same? Does the data show similar dispersion patterns, or some months have more variability than other months? And is the data symmetrical? Is the distribution of data points either side of the median equal in terms of the first and third quartiles and the max and the min values? So answer that completely. Don't more details better than less detail for answering that question. Okay, so that finishes part A. Let's now look at part B. So I'm going to close this Excel data sheet, and now you download and open a file called lab2sciencegrades.zip, and in that file there are two files. There's an Excel file, which is open right on my screen, and that's where we're going to calculate out a variety of different descriptive statistics. And then there's another file that's to be used with SPSS to create box plots. So just like in the first example, there's a box beneath the actual data where you'll do your calculations. So as I said, you've got 6 academic years from 1916 to 2017, and then the final year is 2021 to 2022, and then the courses are listed and the average grades given in those courses. And we want to calculate out mean, median, minimum value, maximum value, range, first quartile, third quartile, and interquartile range for this data. So let me begin with the first column of data, the 2016-2017, and I want to calculate out median, and I'll type in the function, which is average, and select my array of numbers. Now what I'm going to do is I'm going to select a little bit lower, so that when I copy and paste, it will capture all of the additional courses that occur later on in the data set. So there I got a median of 68.7, or sorry, mean of 68.7. I want to calculate out the median equals median, open bracket, and once again I'm going to select a little bit lower below where the actual data starts, and there I've got my median value. Minimum value, so equals min, and I select my values and return the minimum value is 51 or 58.1. Maximum value equals max bracket, select my data, return, and there's the maximum value. The range is going to be simply the maximum value, select that cell, subtract it from the minimum value, and the range is about 20.7%. First quartile equals quartile is the function name. Don't use .ex or .inc. We just want plain old quartile. Open bracket, select my values, oops, then comma 1 and return, and it comes up with 64.3. I'm just going to double check something here just to make sure that doesn't do something weird by not selecting the exact value. 64.3, yeah, is the answer. Third quartile equals quartile, comma, select the data set, and I got put comma, I want number 3, put a 3 in there for third quartile, return, and it comes up with 73.1. And then finally, interquartile range is just going to be the third quartile subtracted from the first quartile, and I got 8.8. So now you just copy and paste into the remaining 5 columns, and you've got all your answers. Okay. So next step is we're going to, so that completes question number 6. Put your numbers into the table that's in the data sheet. I'm going to close this Excel file, and here in front of me is the file, the SPSS file, open. And the data is organized, so first column says year, second column is course, third column is all the grades, and then there's individual columns for each year with the grades. We're interested in just the year column and the average column when we're creating these box plots. And let's create the box plots. So we go to Graphs, Legacy Dialogues, Box Plot, and I want to make sure it's selected as Simple and Summaries for Groups of Cases. Then I press Define, and I put in for a variable my average grades, and then it's going to be organized in terms of the category axis by year, and I'm ready to press OK. And of course, in SPSS, a new window opens, an output window, and that's where our graphs will be. Now, SPSS does a funny thing in creating box plots. If there are no outliers, then the whiskers extend from the minimum value to the maximum value in the data set. So that's what's happening here in 2016-2017. An outlier was identified in the last 3 years. Now, how is an outlier determined? Is it a value that falls outside of the fence defined by the interquartile range times 1.5? And that creates this fence, and we talked about it in class. And so you extend that value, that 1.5 times the interquartile range below the median and above the median. Are there any values that fall outside that? If there are, then they're identified as an outlier, and the minimum is defined by the next lowest value. So that's what happens here, right? The next lowest value it becomes the lower limit for the bottom whisker. So for 2021, there's 4 outliers that are identified. So these two are above 1.5 times the interquartile range, and then the next value is defined as the maximum, and that's the end of the whisker. Below the median, extend this to 1.5 times the interquartile range, and there's 2 values below that. They're identified as outliers, and then the next lowest value is identified as the minimum value in the data set, the bottom extension of the whisker. Okay. So question 8 asks you to explain that process, which is a little bit complicated. There is a link there that repeats that, and so copy that out carefully so it shows that you took the initiative to figure out exactly how a whisker is created. That ends the help file for Lab 2. Good luck with it.